Okay, for section 5.3 and 5.4, which we're doing together, you're going to need your identity sheet and you're going to need your exact value sheet. So if you don't have your exact value sheet, you need to look on with somebody. I don't have any extras, or pull one out because you'll need both of those for this. All right, the identities out of 5.3 and 5.4 that we are covering are the sum and difference identities and the cofunction identities, which are not on this sheet, but I will put them on your identity sheet for your test. Sum and difference identities are 5.3 and 5.4. Okay, so this. All right, the first thing I'm going to do, though, before I get to sum and difference identities, I want to look at your cofunction identities, because this is a review. We have done cofunction identities before. We did them way back in chapter 2 or 3. You may not remember that. But when we talked about cofunction identities, I talked about sine and cosine being cofunctions if the angles added to, does anybody remember what they have to add to? 90. When you have cofunction identities, your angles always add to 90 degrees. That is the main thing you need to remember. Now for cofunctions, sine and cosine are cofunctions if the angles add to 90 degrees. So the cosine of 90 minus theta is the same thing as the sine of theta. And the sine of 90 minus theta is the same thing as the cosine of theta. Because they are cofunctions, the angles add to 90. Tangent and cotangent, these two right here, are cofunctions because their angles will add to 90. So the tangent of 90 minus theta is the same thing as the cotangent of theta, and the cotangent of 90 minus theta is the tangent of theta. And last but not least, secant and cosecant are cofunctions. So this should be the cosecant of theta, and this should be the secant of theta. Okay? Now, for these problems, find one value of theta or x that satisfies the following. The secant of theta is the same thing as the cosecant of 62 degrees. They want to know what can theta be. Well, remember, those two angles, this angle and this angle, have to add to 90. So theta is going to be whatever 90 minus 62 is, which would be, what, 28 degrees? So theta is 28 degrees. Now, you can always check yourself. You can type this in the calculator, the secant of 28 degrees and the cosecant of 62 degrees. You type that in, you should get the exact same decimal. Remember, you need to be in degree mode, though, to put it in your calculator. Gotta think about lots of stuff, but you can check it to see if you're right. Do what? You believe me? She believes me. She's trusting me. All right, well, what about this one? Tangent of theta is equal to the cotangent of negative 54 degrees. What do you know about this angle and this angle? They add to 90. So all you do is take 90 minus negative 54 degrees. And that's the same thing as 90 plus, which looks like it's 144 degrees. So the tangent of 144 degrees is the same thing as the cotangent of negative 54 degrees. These two angles add to 90. Okay. Now following, they have to add to 90. Alrighty, for this one, the cosine of x is equal to the sine of 7 pi over 6. Ooh, we probably don't want to do radian measure, but you could. It'd probably be easier to change this to degrees. Alright, so that's the same thing as the sine of 210. So you know x and 210 have got to add to 90. So how can you find x? Same way we've been finding it. Every time we're taking 90 minus that angle. So just take 90 minus 210. So x is going to be negative 120. Assuming I subtracted right. But what's the matter with the answer? Not that it's negative, it can be negative. It's not in radian measure. They want radian measure, so go back to radians. Right. So x is negative 2 pi over 3. The angles add to 90. Now they didn't put an example like this, but there may be one on homework. What if you have something like this, the tangent of 60 plus theta equals, and they want you to write it in terms of your cofunction. You're going to have to write two things. First of all, you got to write the function, and then you have to write the angle. What is the function? Cotangent. The angle. What is going to go there? Not just theta. Do the same thing we've been doing every time. Exactly. Take 90 minus 60 plus theta. Subtract the whole thing. That's what we've done every time. And when you run your negative sign through there, that's 90 minus 60 minus theta. 90 minus 60 is 30. So 30 minus theta should go right there. And if you'll look at these and add them together, these add up to 90 because the thetas subtract away. So they always add to 90. All right, so cofunctions. Do it with cofunctions, okay? Now, let's go back to page 1 and look at our sum and difference identities for cosine. All right, section 5.3 is only the identities for cosine. Now, they're starting with this difference identity, the cosine of A minus B, and the first thing they do is they tell you what it is not. It is not the cosine of A minus the cosine of B. You cannot distribute because this whole thing is your angle. A minus B is the angle. You cannot distribute the cosine into that parentheses. That makes no sense. It is a formula. The cosine of A minus B is this formula right here. And the cosine of A plus B is this one. All right, I'm going to write these down. If you write them down, it might make it sink in a little bit better. But the cosine of A plus B is the cosine of angle A times the cosine of angle B minus the sine of angle A times the sine of angle B. It is a formula and it has to be calculated that way. The cosine of A minus B is the cosine of A times the cosine of B plus the sine of A times the sine of B. Notice these formulas are very similar. Opposite signs, exactly. Exactly. All right, now you may want to say, how in the world are we going to use this? Well, we're going to use it for exact value. When you see the word exact value, what should come to mind? This exact value sheet, exactly. They want us to find the exact value of the cosine of negative 75 degrees. Well, you could look all day long at your exact value sheet, and you're not going to find 75 degrees on here. You're not going to find negative 75 degrees on here. So the way you use this sheet is to find two angles that are on this sheet that will either add to give you negative 75 or subtract to give you negative 75. But 5 pi over 12 is not on here either. So you need to go look at two angles, any two off this sheet, and let's go for subtraction.
120 minus 45.
All right, can it be, is it 120 minus 45? Is that going to be the correct way to write it, to get negative?
Negative 10, no. I need to regroup. It's going to be 120.
My only,
Negative 45 plus 120? Is that the same? Oh,
no, I'm just saying.
I'm here. I'm here.
Could you do 45 minus? Did you say 45? Weren't you using 45 and 120?
Uh-huh.
Is 45 minus 120, is that negative 75?
Mm-hmm.
All right, if this gives you negative 75, then you can use it. You could pick any two angles on there. They just have to be in the right order to give you the negative 75. Okay. So when you subtract, this is going to be A, this is going to be B. So this is the cosine of A minus B, which is this formula right here. So I need the cosine of 45 degrees times the cosine of 120 degrees plus the sine of 45 degrees times the sine of 120 degrees. Just use the formula. Did you have a question? Nope. Exact value. Right, we're going to have square roots because the cosine of 45 degrees, square root of 2 over 2. Look at your sheet and find the cosine of 120. Cosine of 120 degrees is negative 1/2. Sine of 45 is square root of 2 over 2. The sine of 120 is square root of 3 over 2. So we had four numbers that we pulled from our exact value sheet. Now you just do your arithmetic. Multiplying fractions, you multiply the top numbers together and the bottom numbers together. So that's negative square root of 2 over 4 plus square root of 2 times square root of 3 is the square root of 6 over 4. And they're probably going to write this as one fraction. Negative square root of 2 plus square root of 6 over 4. And that is the exact value of the cosine of negative 75 degrees. Okay, what's your question? You got it? Okay. All right, well, let's try another one, and then let's see if you have any other questions. All right, the cosine of 17 pi over 12. Well, once again, 17 pi over 12 is not on your chart, but change it to degrees, and let's make it easier. Multiply by 180 over pi, and that's going to be, they're asking us for the cosine of, what is that? 255 degrees. All right, again, that exact value is not on here. So find two angles. This time let's go for addition. Somebody give me two angles that will add to give me 255. All right, 210 plus 45. All right, so this is the cosine of A plus B. It wouldn't have mattered because it's addition. That's right. So now we're doing the A plus B. So go back up here and get your A plus B formula. So you need the cosine of 210 times the cosine of 45 minus the sine of 210 times the sine of 45. Then put your parentheses. There are four numbers that you need to get off of your exact value sheet. The cosine of 210 degrees, I believe, is negative square root of 3 over 2. Cosine of 45 is square root of 2 over 2. Sine of 210 is negative 1/2. Sine of 45 is square root of 2 over 2. Everybody following where we're getting the numbers and the formulas and everything, right?
Yes.
Okay. Now do the algebra. You multiply negative square root of 3 times square root of 2, and 2 times 2 to give you 4. And this is going to give you a positive square root of 2 over 4. And again, this will probably be written together. So negative square root of 6 plus square root of 2 over 4. It looks a lot like this last answer, but just be careful, the signs are different. This is the exact value for the cosine of 17 pi over 12. Yes?
Will there be a time where the denominators don't match?
I don't think so. I think every time you do this, your denominators are going to match. Okay. On this example C, this is an exact value problem also. But, oh, okay. Yes. As I did. Okay. All right. This is an exact value problem also. But the cosine of 173 degrees is not on this sheet. So this is actually the formula already written out. Notice, this angle and this angle are the same. This angle and this angle are the same. So this is like the cosine of angle A times the cosine of angle B plus the sine of angle A times the sine of angle B. This is which one of those formulas already written out? It's the second one, right? It's the cosine of A minus B. This is the cosine of A minus B. This is A, this one is B, so this is the same thing as the cosine of 173 minus 83. 173 minus 83 is 90. So the cosine of 90 degrees, now look at your sheet, and the cosine of 90 degrees is 0. Letting you know? No, you had to work that one out. That's it. 0 is the answer. Okay, your question is about this one? Okay. Because a minus and a negative number made it positive. All right, any other questions about these three problems? Okay, I'm not going to turn yet. Yes. Oh, I went back up here to my formula, and I matched it with my formula. So I saw that it was cosine A, cosine B, plus sine A, sine B. So it had to go with this formula, which meant I had to take A minus B. So that's how I figured out the A minus B. I saw another hand, I think. Oh, I'm sorry. Where did I get the 83?
Oh, the 180. Letter B.
The letter B.
180 over 5. At the top of the bracket.
Top. Oh, I'm sorry, right here. Oh, how did I get this? Oh, I had 17 pi over 12. And to get it back to degrees, you always multiply by 180 over pi. Is that your question? So then I canceled the pi's, and then I multiplied 17 times 180 divided by 12 to get the 255. Is that your question? Okay. All right. What other questions before I flip this page? Okay, I'm skipping all the way now to 5.4. The problems for this are the same, except we're using the identities for sine and tangent. These are formulas also, and we're going to use them the exact same way. So let's write down these formulas.
Okay, so we're not doing...
Yeah, we are. We're just going to come back to that.
Oh, okay.
I'm doing all the problems that are alike first, and then I'll come and do the different ones, okay? There's method in my madness. I promise. All right, for the sine of A plus B, again, this is a formula. You cannot distribute to write the sine of A plus the sine of B. I mean, that's just illegal. So the formula for sine of A plus B is the sine of angle A multiplied times the cosine of angle B plus the cosine of A times the sine of B. This one is plus. Now the sine of A minus B, it's going to be the same except for the sign in the middle, sine of A, cosine of B minus cosine of A times the sine of B. Again, that's a formula. Yes. All right, then for the tangent of A plus B, these are the more complicated looking ones because they involve a fraction. The tangent of A plus B is the tangent of A plus the tangent of B divided by 1 minus tangent of A multiplied by the tangent of B. And then again for tangent of A minus B, it's going to be the same, but the signs will be changed. This will be the tangent of A minus the tangent of B divided by 1 plus the tangent of A times the tangent of B. Now, just be glad you don't have to memorize these. All right, you will have these formulas in front of you. You've just got to use them. Read correctly, okay? Yes. Yes, you'll have these formulas on your final also. All right, so exact same type problems. We're using exact value, and we want the sine of negative 15 degrees. Again, 15 and negative 15 are not on your exact value sheet, so find two angles that subtract. Okay, so 30 minus 45, and order matters again. 30 minus 45, so this is A and B, so the formula for this is the sine of 30 degrees times the cosine of 45 degrees, let me get my signs right, minus the cosine of 30 degrees times the sine of 45 degrees. And again, everybody's following where I'm getting the formulas and all this stuff right? All right, so 4 numbers from your exact value sheet. The sine of 30 degrees is 1/2. Cosine of 45, square root of 2 over 2. Cosine of 30, square root of 3 over 2. The sine of 45 degrees, square root of 2 over 2. Again, it looks like it's going to look almost like those other problems. You have square root of 2 over 4 minus the square root of 6 over 4. Square root of 2 minus the square root of 6 over 4. Exact value. All right. You with me? All right, let's do a tangent problem. Again, it's probably the ugliest looking one because of the formula. They want the tangent of 13 pi over 12. Somebody changed 13 pi over 12, 195. So they want the tangent of 195 degrees. All right, now what you need, since 195 degrees is not on the sheet, you want two angles. Let's do addition, but you could do subtraction. Let's do addition. What'd you say? 150 and 45. Does order matter on addition? No, it does not. And always just make sure these add up to the correct angle, and they do. So this is tangent of A plus B. So we need the tangent of 150 degrees plus the tangent of 45 degrees over 1 minus the tangent of 150 degrees times the tangent of 45 degrees. All right, I'm going to put parentheses where I need numbers. Now I'm going to my exact value sheet to find these numbers. The tangent of 150 degrees is negative square root of 3 over 3. The tangent of 45 degrees is 1. And the same thing goes here, negative square root of 3 over 3 and a 1. Okay. When I drop my parentheses, I have square root of 3 over 3 plus 1. On the bottom, the order of operations, multiply these two first, and then it's going to be 1 plus the square root of 3 over 3. Are you with me to this point? Okay, you're all with me to this point. You cannot leave your answer like this for a lot of reasons. First of all, you've got fractions on top of fractions, and you're adding and all this mess. And you've got a radical on the bottom. You've got lots of issues to deal with. No, because if you put a calculator, it's going to give you a decimal answer, and you can't give a decimal answer. They want exact value, which is not a decimal. So what you need to do, what I would do to work this problem, the first thing I would do is get rid of the fractions here and here. I do that by multiplying by the denominator. Multiply everything in this problem by 3. I'm going to multiply everything by 3 so I can get rid of my fraction. Okay, what's your question? No, you'd multiply by the common denominator, which would be 6. Okay. But this one is the same, so we're going to multiply by the denominator, which is 3. So when you multiply this by 3, you have negative square root of 3 plus 3 times 1, which is 3. On the bottom, 3 times 1 is 3, and 3 times the square root of 3 over 3 gives you the square root of 3. That by more than that. All right. When you have two things added, you have terms on the bottom. Do you remember the conjugate? Or does that word sound familiar? 3 minus the square root of 3. Yes. Could I rework what one more time? Just multiplying 3. 3 times this, these 3 cancels and leaves you with negative square root of 3. There's my negative square root of 3. 3 times 1 gives me 3. Then 3 times that 1 gives me 3. And 3 times the square root of 3 over 3, those 3's cancel and leave me with the square root of 3. I'm sorry? No, I cannot make that negative 1. That's canceling terms, and that's illegal algebra. It'd be easy if we could, couldn't it? Excuse me. What we have to do is multiply by the conjugate. Excuse me. Which is 3 minus the square root of 3. All right, we've got to FOIL that out. We'll go down to the next line just because I've got to run out of room. When you multiply 3 times negative square root of 3, that's negative 3 square roots of 3. Negative square root of 3 times negative square root of 3 is positive 3. Alright, so I did outside. Now I'm going to do inside. 3 and 3 is 9. 3 times negative square root of 3. Negative 3 square roots of 3. On the bottom, 9 minus 3 square roots of 3 plus 3 square roots of 3 minus 3. Right here, you mean? Yes, those zero out. And 9 minus 3 on the bottom is 6, which is what you were trying to do. You were trying to get rid of the radical on the bottom. We got rid of it, so that's great. Right. So, yeah, you're jumping way ahead of us, but you got it. 9 and 3 right there will add together to give you 12. Negative 3 square roots of 3 and negative 3 square roots of 3 is negative 6 square roots of 3. Now there is one more step to simplify this. Everything gets divided by 6. So 6 into 12 is 2. 6 into that 6 is 1. And 6 into that 6 is 1. So the answer is 2 minus the square root of 3. We finished with the trig way up here, by the way. This was all algebra. Your question's what? Because why am I multiplying top and bottom by 3 minus the square root of 3? To get rid of the radical in the bottom. You cannot have it, it's multiplying by the conjugate. You cannot have a radical in the bottom of your fraction. You always change the sign in the middle, yes. It's called the conjugate. Okay, like I said, those are the most difficult. Yes. There can't be a lot of anything on this test because of the identities, though, but there's enough of them. All right, what about this one right here? Tangent of 100 minus tangent of 70 over 1 plus tangent of 100 times tangent of 70. This is an exact value problem, but these are not on the sheet. So what do you think you're going to do?
It's tangent A minus B.
It's the tangent of A minus B, which makes it 100 minus 70, which is the tangent of 30. And the tangent of 30 degrees on your exact value sheet, the tangent of 30 degrees would be square root of 3 over 3. Okay. I hope if I put one like this on the test that y'all do get it right. Okay. Any questions about these exact value problems? All right, now I'm going to go back and work that problem that you thought I was skipping. I didn't skip it, it's just different. You probably were just hoping. Okay. Classroom example 3. This is back to section 5.3. Find the cosine of s minus t. This is a formula. So please think formula when you see this. And the first thing I would probably do is go and find my formula. So the cosine of s minus t is the same thing as the cosine of a minus b. So I'm going to write my formula down so I'll know what I'm dealing with. The cosine of s minus t is cosine of s times the cosine of t sine of s.
Can I change it to A and B if I want to?
Yes, you can. Remember which one is A and which one is B, though.
Okay.
Okay. Now, here's what we're given. The cosine of angle S is 15 over 17. The sine of angle T is negative 24 over 25. S and T are both in quadrant 4. here is my formula. Just like everything else, I have got 4 things that I have got to put into this formula. They will always give you 2 of them. What 2 did they give me? They gave me the cosine of s, which is this one right here, as 15 over 17. And they gave me the sine of t, which is down here, as negative 24 over 25. Are we good so far?
Yes.
Okay. We've got some missing items, 2 missing items. We're missing the cosine of angle t, and we're missing the sine of angle s. Think about it for a minute. Where are you going to get, let's say, the cosine of angle t? Yes, you would. Exactly. You would take this information about angle t and the fact that t is in quadrant 4, and you draw a triangle.
Why couldn't you take that?
Well, you can take s, but that's going to go for when we do this one. But right now we're looking for the cosine of t. So we're going to go over here, and we're going to, for angle t, we're going to put angle t in quadrant 4. So here is angle t. This is for t. We know that the sine of this angle is negative 24 over 25. I know this is my hypotenuse, it's 25. Where is the negative 24? It is going down, right? The negative 24. If I want the cosine of this angle, I need x. And you're going to, Pythagorean Theorem. So 25 squared is negative 24 squared plus x squared. So let's see what in the world we're going to get x to be. Alright, when I square this and subtract it, I got 49 is equal to x squared. And I take the square root of both sides. So x is plus or minus the square root of 49. So x is either positive or negative 7. Which one? Positive 7. So the cosine of this angle t is 7 over 25. Everybody got where that came from? The other item I'm missing is s, the sine of s. So take the other information. I know s is also in quadrant 4. So for angle s, it is also down here in quadrant 4. The cosine of this angle is 15 over 17. I know that the 17 is my hypotenuse. The 15 is the x. Use your Pythagorean theorem to find this side. So what is that? Yeah, I think I'm going to get 64 is equal to y squared. So y is either plus or minus 8. Which one? It is a negative 8. So the sine of this angle is negative 8 over 17. Everybody follow where we got the stuff? At this point, just put it in your calculator and put the answer down. Don't give them a fraction. Hit math fraction to, yeah, hit math fraction. Ooh, that didn't look right. Oh, I typed mine in wrong. Who's got an answer? Yes. Yes. Anybody get an answer? I typed it in wrong. You're almost there, okay. It's going to be a big fraction. I think that's right. Yes. 297 over 425. And yes, these will have the same denominators. For angle T, they'll have the same denominators, and for angle S, they'll have the same denominators, always. $297 over 425. Okay. Now, they have the same type problems in section 5.4 that involve sine and tangent. So let's look at those and make sure we get this. So this is in section 5.4. We've got A and B in standard position. At least they're using the right letters this time, right? A's and B's. The cosine of angle A is negative 7 over 25. A is between pi and 3 pi over 2. Sine of B is negative 3 over 5. B is between 3 pi over 2 and 2 pi. Find the following. The sine of A minus B. It is a formula. Write it down. So the sine of A minus B. Where do I see what? Alright, so I have sine of A times the cosine of B minus the cosine of A times the sine of B. I need 4 things to put into my formula. Once again, they're going to give you 2 of them. They gave me the cosine of angle A, which is this one right here. So this is negative 7 over 25. And they gave me the sine of angle B, which is right here. That is negative 3 over 5. So once again, they give me 2 things, and I've got to find 2 things. Yes, what's your question? Because you need it. Why do we need this stuff? What is this telling us? Exactly. This is telling you the quadrant. You've always got to know the quadrant so you know whether your function is positive or negative. So for angle A, this is our angle A information. What quadrant is it in? If A is between pi and 3 pi over 2, where is angle A? Exactly. It is down here in quadrant 3. Because remember, A is 180 degrees and 3 pi over 2 is 270. So A is in quadrant 3. And the cosine of this angle is negative 7 over 25. So this is my 25. And negative 7, correct. Time out what? Got it? All right, has anybody found X for me? Y'all letting me do all the work. Positive or negative? X is going to be positive or negative 24, but I'm over here. Exactly. X is negative 24. So the sine of angle A is negative 24 over 25. I was wondering if anybody would pick up on that it is the same triangle. Now for B. Angle B is between 3 pi over 2 and 2 pi. So where is B? Quadrant 4. Here is angle B. The sine of angle B is negative 3 over 5. Here's the 5. This is the negative 3. What is the length of my x? I think I heard somebody say it. It's going to be 4, positive 4. So the cosine of angle B, 4/5. And that at this point it goes into your calculator. So what in the world do we get? If I type this in right, I got negative 117 over 125. Time out. She didn't want me to say the word. Say it. I'll just write it. All right, that's the sine of A minus B. Negative 117 over 125. Next, the tangent of A minus B. It is a formula, but all the work is going to be here. Did you not get this?
I did.
Okay. I was say you just need your glasses on. All right. Tangent of A minus B. It is a formula. The tangent of A minus the tangent of B. 1 minus tangent of A times the tangent of B. Parentheses where I need them. We drew our triangles. We've got everything we need right in front of us. The tangent of angle A. Here is angle A. What is the tangent of this angle? Shouldn't it be? Cosine of angle A should have been adjacent over hypotenuse. Thank you very much. No, nothing's wrong. I just had the picture wrong, so guess what you get? Walt gets 5 points on his test. Because I do stupid stuff and I expect y'all to catch it. And I expect you to call me out.
So the
Yes.
answer's still right.
Yes, 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 yes. I got too much going on here. Let me write his no, this. Now the formula, this is for tangent A minus B. I think this one's supposed to be plus down here. Yes. You don't get 5 points for that one. What else did I mess up on? Okay. Let's not go on feeding frenzy here, okay? I mean, just because one person gets it. But thank you for calling me out. But I don't think it changed anything on our answers. Because my brain was doing it backwards. I apologize to whoever I'm recording this for. I apologize. I'm sorry. Okay. All right, so do I have my formula right down here for tangent? All right, well, let's get back up here then. So now can we figure out what our tangent is? Okay. What is the tangent of angle A? 24/7. Negative divided by negative is positive. So it is 24/7 for angle A. You put it here and you put it here. Yes. Sorry. What is the tangent of angle B? -3/4. Now, if I were you, I would put this in my calculator, but I would be very careful. I would put the numerator in, get my fraction, and then the denominator. And I believe this is 117/28. Oops. this is a negative 11 over 7. And when I divide, I got negative 117 over 44. Oops, sorry. Question? One last question. A thinking question. Where is angle A minus B? What quadrant? And don't say anything. Don't guess until you have looked at what you've got. You're going to determine the quadrant of A minus B by looking at the positive and negative signs of these functions. Okay, when you got the sine of A minus B, the sine of angle A minus B is negative. You got the tangent of A minus B to be also negative. A smart trig class, quadrant 4. Does everybody know why it's in quadrant 4?
Yes.
Okay, good. I need to stop that.